For centuries, Roman legions ruled the battlefield not just with discipline and strategy, but with a mechanical precision that few ancient peoples could match. At the core of that technological edge was a machine that didn't roar like war drums or whistle like arrows. It just struck silently, deadly, and unseen. Its name? The Ballista. This device could shoot iron bolts over 100 kilometers per hour, pierce shields and armor, and still keep flying. Its impact was absolutely devastating. It didn't just cause death, but panic too. Yet, hardly anyone today remembers this gem of Roman engineering. While the Romans perfected the ballista, its roots go way back to the cleverness of the Hellenistic Greek world. The story starts with a simple device called the gastra phaetes, or belly bow, made in the 5th century BC. This early kind of crossbow used the power of the body to draw the weapon and shoot projectiles with more force than a traditional bow. But the real game changer happened in the city of Syracuse, Sicily, when the tyrant Dionysius I hired full-time military engineers, something unheard of in the Greek world. From their workshops came the first torsion-powered machines, using twisted sinew or hair cords that stored explosive energy. That's how the first true catapults and ballistae were born. During the siege of Tyre in 332 BC, Alexander the Great used these machines, not just to attack walls, but to clear enemy archers off the battlements before the final push with their siege towers. Artillery was no longer a luxury for sieges. It had become an extension of the army in the field. However, the Greeks never fully incorporated these machines into their military tactics. They used them sparingly, mainly defensively, as backup tools. It was the Romans who recognized their much greater potential as a way to enforce control, accuracy, and terror from a distance. When Rome started its campaigns in the eastern Mediterranean, it came into contact with the Hellenistic kingdoms that were already using these weapons: Syracuse, Macedonia, the Seleucids. The Romans, obsessed with organization and discipline, didn't just adopt these machines. They standardized them, adapted them for open battlefields, and spread them throughout the empire. The turning point was the siege of Syracuse in 214 BC during the Second Punic War. Roman troops, led by Marcus Claudius Marcellus, faced fierce resistance. According to Plutarch and Livy, Archimedes himself designed machines that defended against the Roman attacks with almost supernatural precision. There were bolts that destroyed ships, heavy stones dropped from above with crushing force, and machines that aimed so accurately it was like they had a mind of their own. Although Syracuse eventually fell, the Romans took note. From then on, artillery was no longer just a side tool. Occasionally, they became a key part of every campaign. By Julius Caesar's time, there wasn't a Roman legion without artillery engineers, the ballistae, and a full set of ballistas, from portable ones to huge siege engines. At Alesia and Avaricum, Caesar used these machines not just to break down fortifications, but to control the perimeter, stop enemy sallies, and keep constant fire on the defenders. The ballista didn't just kill, it also helped manage the chaos and stuff like that. It was deeply Roman. At first glance, a Roman ballista might look like a giant crossbow mounted on a wooden frame, but it was way more than that. It was a piece of precise calculation and design. It wasn't about brute force, but about mathematical accuracy. Every part of the ballista was measured according to proportions set by engineers like Vitruvius, the famous architect from the 1st century BC. For the Romans, a weapon like this wasn't made on a whim. It was designed like a deadly equation: wood, metal, and tension. The heart of the ballista were its 2 vertical columns called chick pieces, which held the torsion springs, thick ropes made from animal tendons or even human hair twisted and soaked in vinegar to keep their elasticity. The more tension, the more energy stored. When the throwing arms were pulled back using a crank handle, the ropes compressed with explosive force. Let go of the trigger and that energy was released instantly. The arms swung violently forward. It wasn't a curved shot like a catapult's. It was a straight, silent, sudden line, almost always deadly. In the center, between the arms, there was a long, smooth groove called the canalis. That's where the iron bolt or dart, which could be up to a meter long, was placed. This guide ensured a precise trajectory when fired. Some advanced models even had metal-reinforced channels to boost durability and prevent deviation. Everything was designed to maximize efficiency. The size of the hole where the ropes went, the length of the arms, the thickness of the frame. Every measurement followed proportional formulas. It took a coordinated team to tighten the ballista, at least 4 men. One placed the projectile, another turned the winch. A third checked the rope tension, and the fourth gave the signal. Firing a ballista wasn't just about pulling a rope, it was a meticulous operation. Also the valistari. They had to keep the weather in mind. Humidity could loosen the tendons, and extreme heat could make them shrink and snap. That's why these experts often adjusted the tension several times a day, almost like tuning a musical instrument. One wrong move could mean a missed shot or a broken machine. Thanks to this standardized design, the parts of a ballista could be made separately, easily transported, and assembled in just a few hours anywhere. Empire. The legions didn't just carry soldiers, they also brought boxes filled with bronze screws, tendon springs, numbered wooden parts, and assembly manuals. It was military logistics like never seen before. Every Roman camp had raised platforms at the corners to set up ballistae. From there, they could cover the entire perimeter, keeping night attacks or cavalry ambushes at bay.